Right, hello everybody. How is everybody? I really appreciate your patience tonight. I've had a few difficulties with relation to work commitments, so I really appreciate the fact that you've been waiting for me all this time. Just to confirm if you can hear me, just give me a thumbs up on your screens just to make sure. Yes, it's lovely when something works, isn't it? Okay, so just to describe tonight's situation, guys. Look behind me, it's a clear sky. How exciting is that? So what I have done is I've now got a live feed to present to you of the moon. So I'm delighted to share out with you in just a second. And so just to run through a couple of things, I believe more people are gradually entering the talk as with other times. And just to say hello to you all, thank you very much for coming to my next Space4All workshop.
Hi, Josh.
Hello, Jack. How are we doing?
Hi,
Oh, good.
Hello, everybody. It's lovely to see all your lovely faces, and thank you for supporting me as well with this and your patience as well tonight. Okay, so shall we get tonight on the roll then? If I could please ask for everybody to mute themselves for the time being, and we're going to have some fun activities where I'll ask you to turn off your turn off your mute on your microphones, as it were, and we'll do some fun activities that way as well. Okay, then. So first of all, then we will begin by sharing the screen for the workshop itself. I'm going to present that. Okay, and just wait for this to load. Let's have a look. Here we go. So everyone should be able to see this one. Can they everybody see the Space4All logo? Yeah, just a quick thumbs up. Yes, lovely. Okay, so just for people gradually entering the talk, I'd just like to say thank you very much for coming to my virtual astronomy workshop on the moon. As you can see, I am sitting here in the pitch black in my garden in the cold doing this for you guys. So tonight I will be teaching you how to observe the moon. So just to begin with them, I'm going to create a new screen share and we're going to see what the current state of play is on the moon. So here we go, guys. This is live from my telescope and this is what we can currently see of the moon. Look at how beautiful that is. I'm just going to try and get my telescope moving as well, just to help with this. So just to explain tonight's talk, we're going to be talking about the basics of one of our natural satellites, the moon. We are looking at an object where mankind has once stood on the surface of another world. How amazing is it to think that men have once stood on the moon? And the most exciting thing about this, look at all the surface detail we're seeing. We're seeing craters, we're seeing lunar seas formed by lava, which has since cooled to leave these unusual colors and textures. It's a stunning sight to see. I'll just try and get the focus a little bit better. There we go, that's fractionally better. But we can see mountain ranges on the lunar surface. How exciting is this? Look at the features you can see. Honestly, it's one of the most exciting places for me in terms of an astronomer. Why? Because everybody can see it. You do not need a telescope necessarily to observe the moon. All you need is your unaided eyes and that you're able to observe alone. And if you want to get more serious and see more exciting details, we can do this with binoculars and telescopes. So already there's loads to see. But what I'll do, I've got some things for you to see anyway this evening, but I'll go through my presentation anyway. And if anybody would like to see a certain part of the moon, give me a shout and I'll do my best to help you with that. So I'm just going to change my screen share now. Back to the presentation itself. Okay, here we go. So I'll just gradually get this to load. It's a little bit difficult with the internet connection out here outside, so please be patient with me, guys. So as I've mentioned already, if everybody please could make sure to mute themselves for the purposes of this presentation. If anybody has any questions whatsoever about tonight's talk, please make sure to let me know using the question chat, which is in the group. And honestly, if anything is difficult for anybody or anybody would like to learn more about a certain feature on the moon, then please do let me know. That's why we're all here with Space4All. Space is for everybody. And so that's what I'd like to achieve in tonight's session. So hopefully my screen will load and I'll be able to try and share with you the presentation that I did make especially for tonight. So just bear with me 2 seconds whilst we just deal with a very, very quick technical issue. Otherwise, I've got another plan for this evening. Don't you worry. So how is everybody otherwise? Is everybody doing okay? Have they looked at the clear skies recently? It's been really good the past couple of nights, and I've only heard today actually that we're fortunate in having a pass of the International Space Station, one of the brightest passings in quite a long time, visible at 10 minutes past 8. So it's all very exciting. So I will just invite others to join in the group as well, who are just joining, and try and resolve the situation which I've currently got with my presentation. So please bear with me, guys. It's just to do with the technicalities here. Okay, so let's have a look. Oh my goodness, it's raining down in Dorset, is it, Bob? Wow. 8:08 p.m. over in Essex. That's very true, Jackie. So just keeping up to date with the chat as well whilst trying to multitask rather. Okay, so let me try and make some progress here. Please bear with me, guys, as I just sort myself out. Otherwise, I think the internet is struggling. Otherwise, I've got another adaptation for this talk if we need to, which unfortunately is looking more stronger to be the case, just with the way that my internet's playing up. So I can only apologize, guys. It's a slight technical issue, but if not, I have got some notes which I can prepare in a different form of narrative for tonight's talk. Okay, so I'm going to adopt a new plan for tonight because my technology unfortunately isn't working, which is such a shame. So let's try it this way instead. Okay, guys. So tonight we're going to look at our natural satellite, which is the moon. The moon is an exciting object, and I've just made some notes here as well, so we can reflect on this whilst looking live and virtual at the moon. So as we know, the moon is a natural satellite, which was formed about 45 billion years ago. How exciting is that in terms of a human timescale? However, as astronomers know, this is such a small amount of time in an astronomical unit, but we are looking at one of the Earth's natural satellites, which was formed with the collision of our young Earth in the early formation of the solar system. And it was believed that there was an object which was once the size of Mars, which collided with our young Earth and produced the moon in its orbit. And eventually this spewed some rocky debris and eventually formed an orbit with the moon and was about 1.2 the mass of the Earth. So that's an exciting statistic already just to consider there. But also it is the 5th largest planetary satellite in the solar system. So already this is quite exciting to think in terms of that scale. And as we know, when we go to the beach on our holidays, the moon has an influence on our gravity and the oceans. It's what creates tides. So already there's a lot of science behind the moon and has inspired generations of astronomers and stargazers, ancient and modern, to look up to the night sky. So just whilst we're having a look now, I will do my best just to pan over the surface of this other world. Look at that. And we're so lucky because we've got a clear sky. We don't get this very often as astronomers, but you know, it's good enough when you've got to make best use of any opportunity we have for clear skies. And we've had a couple of those, which has been very fortunate as well. So just to mention a couple of techie, sciencey things as well in the mix, the moon has an elliptical orbit. So for those who are wondering, if you imagine an egg, basically that is the shape of an elliptical orbit. So technically you've got, well, forgive me with my pronunciation, apogee and perigee, or perigee as it's sometimes known. So I've made a note on this where apogee or apogee, however you may pronounce it, is the furthest away a celestial object is. And in this case, just for some exciting terminology, when the moon is furthest away, it is 251,966 miles away. Quite amazing, huh? And then its perigee or perigee is its closest at an apparent distance of 225,744 miles. So it's already interesting because of this elliptical orbit and the nature of this natural satellite that the moon moves away from Earth a couple of centimeters each year. And what I was hoping to do for the purposes of this talk tonight was to show you some of my eclipse pictures. Because if you imagine a total solar eclipse, this is one of the most dramatic celestial events of its kind, where we see the moon totally eclipse the sun's disk. And we see these exciting details, which astronomers like myself know as the chromosphere and the corona, and also prominences, which is effectively lava of the sun spewing off into space. The point I'm mentioning eclipses is because of the moon moving a few centimeters away each year, in about a couple of, or millions of years' time, we will not see a total solar eclipse again. So the orbit of these objects is changing, and this is how we are currently viewing them as well. So just to go back into a couple of details then, I think what I will do now, just to do a time check, we are on 20 minutes past 7, we wasted enough time anyway. I'm going to show you one of the first craters on the surface of the moon. Are we excited for that, guys? A thumbs up there. Let's go. Let's travel across the moon and further into our solar system. So the first crater I'm going to show you is one of the first objects I personally come to know as an astronomer, and this was a crater called Copernicus. It's a very well-defined crater on the surface of the moon, and you'll see why, because of its cratered edge and also the fact that it has a mountain peak inside of it. So let me just locate that for you now. There it is. So I'll just indicate this by my mouse on the screen. Can you guys just tell me if you can see my mouse spinning around on the computer screen? Just a quick thumbs up just to make sure. This is the crater Copernicus. So let me give you a brief description of what we are seeing. So Copernicus, when you're looking at that crater, that diameter which you're seeing on your screen live is 66 miles in diameter. So imagine that in terms of the scale of the moon and how far away it is from Earth. That is 66 miles on your computer screen. And just to mention that it's 800 million years old. That crater there, Copernicus, is 800 million years old and has a crater floor which is 2.3 miles below the crater rim, which we can just about make out here. And inside is a mountain peak, which at this moment in time may not appear too clear on your computer screens, but I'll just bring that into view now because I am aware it's slightly drifting off screen, and I'll bring this into view. Some of you who may be thinking, Josh, why is your screen so wobbly as it is? That is a number of things, and when astronomers observe astronomical objects, we get turbulence. So this is to do with the Earth's atmosphere. Here you go, you can see like a rippling effect. This is all to do with the jet stream, guys. So when we're looking at the moon, we're looking through a layer of the Earth's atmosphere, which is the jet stream. And so our vision can be ever so slightly distorted, and that's the reason why for this. So what I'll ask everybody to do, this will be for a bit of fun, right? I'm going to just change over my sharing opportunities here back on my desktop. Let me get this right very, very quickly. Let me see why this is not being the case. Here's another way. Everybody, I would like you to unmute yourselves. So if everybody can unmute themselves, we are going to practice the name of this crater. Okay? So if everybody can give me a shout just so I can hear you.
Yeah.
All right, Josh.
Hi.
Lovely to see you and hear you all as well. So can everybody pronounce after me? 3, 2, 1, Copernicus. 3, 2, 1. Copernicus. Yes, that's right, guys.
Copernicus.
So you are seeing the crater Copernicus. It's a very well-established crater on the surface of the moon, and for me is one of the targets I would like you guys. Oh, look at this, Jackie Baker, you've got a lovely picture of the crater Copernicus on your phone. That looks stunning. So it looks really good.
There it is, guys.
Yeah, absolutely.
Have a look. Yeah, I'm cheating here.
Yeah.
Yeah, it's lovely.
Right.
And it's a very obvious crater. That's why I've decided to show this to you guys first, mainly because it's such a well-defined feature on the lunar surface. So very quickly then, we're going to move on to another crater now called Tycho. So let me just move my telescope around to show you this. We're going to travel to the Southern Highlands, everybody. And there it is. It's just coming into view now. And I will just set this up on my screen just so it's centered. And that is the crater Tycho. I will just indicate this using my mouse to circle a couple of times just to show you guys the crater which we're looking at here. And this is called Tycho. So it's one of the sharpest defined craters on the surface of the moon. And so what I'll do now is provide you with a bit of background just to explain more about this. And I can see some of my members already showing some images of this crater. It's a truly stunning object, guys. So I just hope this gives you the opportunity for those who don't own a telescope to at least be able to see it live. You have to forgive me. It's like I'm working under candlelight here. This is quite funny. Right, okay, so Tycho, is as I mentioned, is located in the Southern Highlands. And so when you're looking at this crater, you are looking at a crater which is 63 miles in diameter. And also to mention that this crater is 3 miles deep. Can you imagine that in terms of a scale? Like, we have some craters here on Earth, and I'm sure many of you guys have been to them, and you are so lucky if you have, because I've really wanted to do that. But how amazing the fact that we can see this live on our computer screens now. This one is a slightly younger crater, being only 100 million years old. But also, as I mentioned earlier, is one of the most sharply defined craters on the lunar surface, and has a central mountain peak, which you can just make out in the center on your computer screens, which, just referring to my notes, is 1.9 miles high. So already this gives you a lot of perspective when we're looking at the lunar surface. And also what I'd like you to look at as well is there's features called distinctive rays. So I'll just try and point this out the best I can on my computer screen, but can you see this weird pattern on the surface of the moon where you see an almost spider web-like structure emanating from this object? This is to do with the impact of this particular crater. And this is the material which is spewed off onto the surface of the moon. So it already suggests this was quite a rigorous impact on the lunar surface 100 million years ago. And that is, for me, another reason why I choose this as a beginner's object to observe on the moon, because it's got some very easily distinguishable features. So already that's quite amazing to think as well. So just to make a joke of it, underneath candlelight here, so this particular one is 930 miles from the crater rim. So already in terms of these statistics, this is quite amazing to consider. Right then, so Clavius is our next one. Actually, no, we won't do that next. Everybody unmute themselves again, and we're going to pronounce the name of this crater. I love this because I can hear all your guys' lovely voices. So on the count of 3, I would like you to repeat the name Tycho. So on the count of 3, 3, 2, 1.
Tycho.
Tycho! Yes, that's it, guys. Well done. So you're learning the craters as we go along. This is brilliant, and it's a lovely way for us to all engage virtually. It's great. So we're now going to move on to our next object, which is the crater Clavius. We're traveling even further now into the Southern Highlands. So we're going to be right on the edge of the lunar disk here. Clavius is a very large ancient crater, which I will now highlight using the mouse on my computer screen. As you can see, compared to Tycho, Clavius is a much larger crater. So let me provide you some background just to give you some idea of what we're looking at here. So as I mentioned, Clavius is a huge, huge ancient crater and is 140 miles in diameter. So again, a massive object, a massive crater on the surface of the moon. And it makes you wonder, what impacts has the moon had in its history in order to be visible now, millions of years on? So, as I mentioned, it is situated near towards the lunar South Pole, which you can just see on this edge. This is the South Pole, guys, on the surface of another world. And it's believed that there's deposits of ice around the poles. So there's evidence that water could potentially be found also in the solar system. And just to mention that it was impacted from a crater it was impacted from a meteorite impact many years ago. And if you can observe very carefully, you'll be able to see that this crater is peppered with other craters within Clavius itself. So if you can see very carefully, you can see 1, 2, 3, 4, 5. We can see 5 craters inside of Clavius itself. Is absolutely peppered. So when you see high definition photographs of Clavius, there's a lot of details to be observed here with much more professional astronomical equipment. So already this is an exciting feature to observe on the moon, and was one of my personal favorites purely because you could see so many craters, and honestly made me think of Wallace and Gromit when they traveled to the moon to try and eat some cheese. So that's an exciting little thought there for you, just to make this Right then, so we're now covered the main basic craters, but I'll also just cover over a couple more now, just as I'm aware that we're on a time scale of 7:30. And we're going to travel now to the Northern Highlands. Okay, and we'll just get these into view. Just get the right orientation, guys. How does this make everybody feel, being able to see the moon live?
Amazing.
You like it? I'm glad you guys.
Yes, very well.
So I'll try and point out one of them now. However, I'll talk to you about this a little bit later on as to kinds of telescopes you can use to observe the moon. But some of you guys who are very keen avid astronomers may say, Josh, why is the view of the moon inverted around the opposite way? Just to explain to you guys, I'm currently using what is known as a reflector telescope. So this is a type of telescope which is all dependent on the types of mirrors which you use within what's called an optical tube assembly. So this is what houses the mirrors within a telescope, and a reflector has a nature to invert an image when exposed to an eyepiece or another optical aid, which in this instance, just to shout out here, is my friend's imaging camera. So thanks, Mike, for letting me do this. Right, so here I'll be able to show you is another crater. And we can also see another feature, which we'll talk about a little bit later on. I've made a couple of notes here, but this is a mountain range. But it's just lovely to be able to show this to you guys live whilst we can, just to give you a bit more detail about the lunar geography and what we can see. What I'm going to try and do now, guys, just whilst the thought has flickered, I'd like to try and show you, even if it's not too good, another way of being able to observe this document. So, as I mentioned, can everybody see my screen? It's not perfect, I know, but can everybody see a picture of moons? Yeah? Okay then, so as we guys know, during its orbit, we see a change in phases on the surface of the moon. And as astronomers, this allows us to observe different features. And the reason why is because there's a phenomenon on the moon, which we can see in these images here by Fred Espignac, who is a very well-known astrophotographer. And this is a feature known as the Terminator. No, not Arnie Schwarzenegger, not the cool dude, but it's a celestial feature which divides day and night on the lunar surface. And when we're able to observe this, we get contrast. And this means we can observe features like craters and the lunar seas in great definition. This was a brilliant graphic which I managed to find by CPRE, Campaign to Protect Rural England, and demonstrates the different phases which the moon exhibits throughout the month. So we're able to see new moon. So just to briefly describe, this is when the moon is 0% illuminated. And going through the phases, we're able to see what is called a waxing crescent. I'll just highlight this on my screen here as well. So this is the very well-defined crescent edge, which we can see just a couple of days into its lunar cycle, and gradually works towards first quarter. They've described it as waxing quarter, which is fair enough, but as an astronomer myself, I've always known it as first quarter. Waxing gibbous is the current phase we're exhibiting now, so we're going ever closer towards full moon. So after full moon and as its orbit begins to change, we see waning gibbous. So we're now going on the decline. So we're seeing the waning gibbous phases and gradually towards last quarter. So the complete opposite of first quarter, we have last quarter. And then so on, we go towards waning crescent until we're back to exhibit new moon. Some astronomers may say, well, I kind of have a love-hate relationship like Marmite with the moon, because the moon is its natural resource of light pollution in a sense and reduces the contrast of the night sky. However, when we exhibit a new moon, we don't have any light interference from the reflection of light from the sun, and are able to observe truly dark skies from a dark sky place. Now, if you can imagine this on a bigger screen, this is what I was hoping to show you on a much bigger platform here. But I mentioned earlier about the type of equipment to use when observing the moon. So as I've already reiterated, your eyes, any type of binoculars, give it a shot, guys. You'll be able to see the craters and the lunar seas. But in terms of telescopes, just to bring this into clarity, if anybody has one, I personally recommend using a telescope which is about 4 inches in diameter and greater. The reason why is because we're able to resolve a lot more light and light gathering, as it's called, which allows us to use larger eyepieces to focus on these objects. The focal length, just to briefly describe to you guys, is to do with how long your optical tube is. So I can tell you mine, which you're just struggling to see on your screens now, is what's known as a 1,000 mm diameter. So this is effectively a meter long. And the reason why is it just allows, again, the distribution of light, in which allows us to increase the focal length and the capability of our eyepieces when we use them. I'll just flick through these guys because I am aware that we've already covered them, but Copernicus, this is one of the features we've been seeing. Tycho, and as well as Clavius, this is a beautiful image from the Lunar Reconnaissance Orbiter from NASA, a totally different perspective of another world. Now, we're going to go back to track with the Sea of Tranquility. This is a particularly special area on the moon because it is where one of the first Apollo landing sites occurred and where men once walked on the surface of the moon. So let me show you what our current state of play is. Okay. I'll just bring the Sea of Tranquility into view now for you guys. Just coming into view. Here we go, chaps. That dark grey looking feature, which you're seeing near to the center of your computer screens, is the Sea of Tranquility. So if you imagine, just use it. This is very brief, guys, so work with me on this. But where I'm circling my mouse now is the approximate location of the Apollo 11 landing site. I'll go into more details about this, but if you imagine just staring at your screens now in awe and wonder, we're looking at a place where Neil Armstrong, Buzz Aldrin landed on the surface of the moon whilst Collins was orbiting around the moon. This is a big leap for mankind. And you just imagine that all those years ago, we're able to see just that, the surface of another world. How exciting is that, just to even think that we can see these details live on our computer screen? So the Sea of Tranquility has an average diameter of 542 miles. How big is that? That's humongous. And is an impact basin formed around 4 billion years ago and was flooded with lava about 3 billion years ago. So this dark feature which we're seeing here is the result of cooling lava, which we're now seeing on our computer screen. So if I just go back from my screen share onto the actual presentation itself, this is best observed between the phases of waxing crescent to waning gibbous. So it's just one of those features. When you guys are looking up to the night sky next, look for the Sea of Tranquility. The next feature which I'm going to highlight is the Sea of Serenity. So this is another lunar sea, and I'll just share this very quickly with you now. We can see this just neighboring the Sea of Tranquility on our computer screens. I'll just bring this into view now and provide you a bit more background of what you're seeing from the comfort of your living rooms or wherever you may be. I tell you, it's blooming cold out here. Think yourself lucky. Have a hot chocolate on me, will you? Right, so. Oh, look, some people already have by the matter of things. That's hilarious. Okay, so we're seeing the Sea of Serenity on our computer screens. There it is, just central right now. And this particular lunar sea is 435 miles in diameter. So it's just useful giving these statistics for you just to give a sense of perspective of what we're seeing right now. And was formed from an impact 3.9 billion years ago. Look how old the moon is. It's incredibly old. And also in the year 1972 was the place where the Apollo 17 landing site was located just to the southeast edge of the Sea of Serenity. So we've already seen two areas. We've seen Apollo 11, we've seen Apollo 17. We are seeing history on our computer screens, guys. How cool is that, huh? So we'll now go back to my presentation, just to keep us all up to date. Now, just to get ahead of time then, we're looking at another feature, which is called Montes Apennus. Now, if there's any astronomer friends who can help me pronounce this, I'd be much appreciated, and I'm more than welcome for you to unmute yourselves to have a go at trying to pronounce this feature on the surface of the moon.
Montes Apenninus.
Apenninus, thank you, Bob. Montes Apenninus. So this is the Apennine Valley, or so really we're looking at a mountain chain here on the surface of the moon. And for me, it's one of the most exciting objects because we are looking at a mountain range. It's such a lovely feature to be able to observe from first quarter towards last quarter. And we're able to see other features nearby to this mountain range. We can see the Clavius crater. We'll take a look at that in just a second. And also, if we've got enough good visibility tonight, we'll also see a valley, which is called Hadley Rill. So let's have a go at trying to find some of these objects. So first of all, we'll have a look at the mountain range itself. You won't be able to see it in such the same amount of detail now, guys, because of the lunar phase which we're exhibiting, but you can still see the mountain range on your screens, just highlighted here using my mouse on the screen. So we have got Crater Clavius, which is just located here, but also can we see Hadley Rill? I'll be honest with you guys, I can't see it too well at this minute in time because it does involve having the right lunar phase in order to distinguish contrast on the surface of this world. But still, it's fascinating to think that when you're looking at this object, that there are valleys on the surface of the moon, just like here on Earth. So already there's a lot of lunar geography in which we're observing here. So moving on then, because I'm just wary of time, we'll go back to our presentation. And here's another feature, Sinus Iridum. And for me, like my friends down in Dorset will know, it reminds me of a feature that resembles Lulworth Cove down in Dorset. That's how I've always remembered this feature. So I'll just describe what we're seeing here, but effectively it is an impact crater which has been flooded with lava. So we're seeing only a part of these details actually visible now a couple of million years later. So what we're going to do now is have a go at trying to observe this with our telescope. So let's move the telescope and we will carry on across our voyage of discovery as we trek across this ancient world. Oh, here it is. It's coming into view now. Here's Sinus Iridum. So just imagine a cove-like shape, guys. This is how I want you to remember this as a takeaway aspect. And you can best observe this feature from around now, the waxing gibbous phase, but towards waning crescent. So it's one of my personal favorites. It really is on the moon because there's so many details to exhibit on the surface of this world, but also it's so large as well, which allows beginners to be able to see these features with their unaided eyes. So it's just a lovely feature to exhibit now on our computer screens. So going back, what's some more details I can show you in the time we have left? Okay, I'm going to show you, I know you guys have been waiting for it. You want to know exactly where the Apollo 11 landing site is, because I'd tell you, like, I wanted to observe this myself. So we have to remember a particular crater, which I will need the help of my astronomy friends just to know the exact pronunciation of it, but Moltke or Moltke. Can my astronomer friends help me here? Just
that's Moltke.
Moltke, thank you very much. Moltke. So once we have found this crater, we are very close to the Apollo 11 landing site. This, just to reiterate, guys, is located within the Sea of Tranquility. I have some cards to give you guys as a little takeaway aspect from this talk to know exactly where to find it. But once you have found Moltke, you are very close to Apollo 11. It's just to the northwestern edge of this crater. And for me, what I thought was one of the most exciting things to remember about the location of this landing site is that there are 3 craters named in commemoration of the astronauts who first landed or approached the moon all those years ago. So we can exhibit Crater Armstrong, Collins, and Aldrin. How cool is that, guys? So if you try having a look for the Apollo 11 landing site, you're looking at craters which were specifically named after their astronauts on Apollo 11. Like that's history. That is like a sense of reality that hits you there and hard. Men did once walk on the surface of the moon. And just so that you guys know, I have got some more details which you can see just in the lower right corner of your screens. But again, as I've reiterated, I do have some fact cards to take away if you would like to have them at the end of the talk. So I will try and show you guys. You won't be able to see this as such because it's a very zoomed in view, but I can at least show you the rough location of where to find this place on the moon. The Apollo 11 landing site. Let me try and zoom into it. I tell you what, guys, it's a stunning night out here, I have to admit. Okay, I've mentioned it already, but I think it's good for purposes of just trying to engage all of us. But this area here on the Sea of Tranquility is a zoomed up version of where the Apollo 11 landing site is. So that's just for peace of mind for when you look at the moon and you look at your handout, which I'll give you tonight, that is where men once stood on the moon. Going back to our presentation here, I've already mentioned that the moon has many influences in terms of celestial events, as I've already covered with total solar eclipses, but we also exhibit total lunar eclipses. So this is opposite to a total solar eclipse where the moon passes through the Earth's shadow. So just remember one thing, guys, it's an alignment between the sun, the Earth, and the moon. So when light is being cast from the sun and produces a shadow from the Earth, the moon hides behind this shadow and creates this red rusticy-like color, which we see associated with total lunar eclipses. And this is all to do with the particles being reflected in the Earth's atmosphere, which give it this uniquely distinctive rusty red appearance. But again, we see partial lunar eclipses as well, which are all determined by the lunar orbit. So we may not sometimes see all of the moon totally eclipsed. We can see partial phases. So that's just something else to bear in mind. So then, I think that concludes pretty much my coverage, or my live stream rather, of observing the basics of the moon here with you this evening. As always, I'd like to give you guys some further resources for you to look at in your own time. And as always, I love to reiterate these particular books, which I used back when I was 7 years old, which is Phillips' Stargazing Guides. They are superb. They tell you what is currently visible in the night sky on a monthly basis and are great in being able to find dates of particular celestial events. But also a book which I cherish so much, which is a book called Nature Guide, published by DK for Stars and Planets, and has some very good moon maps in there for you guys if you want to venture even further to the surface of the moon and uncover some of the real true gems of our closest natural satellite. A more advanced book is one which I currently own called Observing the Moon by Gerald North. It's a very good guide. It's a bit more complicated for the advanced astronomer to read, but I'd say it's a very good go-to because there's lots of illustrations. You see pretty pictures of the moon, and for me, that's what inspired me to look up to the moon and see it visually. So that's just something to bear in mind. And just a couple of other digital resources for you guys. So there is a good map which I found, which is a 3D moon map. If you guys want to take a note of the link here, just highlighted below, it's a very good digital resource for those who may not have a telescope. So if you fancy taking a look and being able to observe the moon without a telescope, this is a very good resource to have because you can zoom in on the surface of another world and really see the surface details details in high definition. So it's one word I'd personally recommend taking a look at. I'll go over these again, guys, if you want to take more notes, but I'll flick through my presentation as far, because another good one just to mention, if you want to try finding more of the Apollo landing sites, a good resource I can relate to is The Sky at Night. And this is a place which I once worked for and have a good resource to find the Apollo 11 or other 15, wherever it may be, landing sites. So you've just got to really to know the surface of another world and being able to hop from crater to crater to find the rough area for these landing sites. I have to exaggerate that even the most professional telescopes on Earth will not be able to resolve exactly the places of where men once stood on the moon, only because you need extreme magnifications or zoom capabilities to really get some good definition of observing these regions. So that's why we have the likes of the Lunar Reconnaissance Orbiter in order to capture these details. So it's just one to bear in mind that what I'm showing you now is just how to locate the rough regions of where these locations are. So, as you guys may be aware, that this particular workshop was a day early, so I do appreciate your attendance this evening. So the next workshop is going to focus on deep sky objects, which will be looking at galaxies, nebulas, and star clusters, some of the oldest objects in the universe, and some which you can see to the unaided eye, and others which will require a telescope for. So already this is a way of challenging your voyage into the cosmos. So just to make a note, guys, that will be on our April talk. So that'll be on Thursday, the 29th, I believe, if I can read rightly on my small screen here. I have got the details just to confirm at the end of the presentation. And just to note, guys, I would have loved to have shown this a bit bigger, but for technical issues here on my screen, I have to show it small. If anybody would like a handout from tonight on observing some of the major features on the moon, please feel free to contact me and I will send you over a pack of moon features which you're able to observe on the lunar surface. So as we've already covered tonight, Copernicus, Montes Apenus, which I'm struggling to pronounce right now, Clavius crater, the Sea of Serenity, the Apollo 11 landing site, Sinus Iridum, the Sea of Tranquility, and the Tycho crater. So if you'd like a copy of those, please get in touch, guys, and in the chat as well, and I'll do my best to cater for you in your astronomical ventures. And just to remember, guys, the only way that Space4All is going to work as an astronomy community is to spread the word, to get as many of us engaged with looking up to the night sky. So please make sure to follow us on our social media platforms on Facebook, Twitter, YouTube, and Instagram at Space4All UK. And I am currently in the process of uploading some basic astronomy videos on how to look up to the night sky and be excited to learn more about the basics of stargazing. So this ends pretty much our talk at 5 minutes to 8. So would anybody have any questions to present to the board? I shall now go towards my desktop to go back to the actual Zoom call. So just please excuse me whilst I try and figure that out. And here we go. So let's have a look. So if I can just move this out the way. And let's see what we can get at. So let's have a look at the chat. Okay, so as we've already mentioned, we have a passing of International Space Station, which is approximately between 8 minutes past 8 and 10 minutes past 8. And Bob Meisen has just made a comment that he has a brief PowerPoint, 3 reasons why the moon is useful to us, which honestly is a really good resource, guys. Bob really knows his stuff with astronomy and is a very good resource, I am sure, for the beginner. So if you'd like Bob's contact details, please make sure to send me an email, or if you'd like to talk to Bob now during our virtual talk, even now, that would be great. Jackie Burns, I'm using my iPhone to show images of the craters, which you did. Thank you so much, Jackie, for educating us all as well. It's not quite cheating, but it does show the center peaks and edges, which is so true because we need clarity to observe these things, guys, which is so true. And Bob also made a comment, I've also got a piece of basalt here, can show, not from the moon, but is what is mostly made of. Look at that. I've got Bob's view on my computer screen. Look at that, guys. That is the same sort of textures we can see. Isn't that cool?
Yeah, I found this in France in a town called Saint-Flour. There's a big lava cliff there that happened millions of years ago, and you can just pick pieces of this up off the road. It's a moon-ish rock. It's not from the moon, but it's the same stuff.
So how cool is that, guys, already? That's brilliant. Thank you very much, Bob. Just to also mention that Bob Meisen is head of the campaign for Dark Skies, which is also a group which I have been associated with in the past to raise public awareness of dark skies. So just a shout out there for Bob and all the amazing work that you're doing as well for night sky conservation. And I'm also getting some very lovely comments as well. So thank you very much, guys. Does anybody have any questions they would like to ask to the board of us crazy nutters who like to look up at the night sky?
Yeah. Josh, hi.
Hello,
Hi,
Phil, all right?
Yeah, I'm good, thanks. Sorry, I'm a bit dark here, aren't I?
Oh, don't worry, you can't be much darker than me. I'm just seeing my head.
That's true, yeah. Thanks for that. It was really, really interesting. I've got a question.
Sure.
Some of these craters on the moon, which was obviously facing the Earth, they're absolutely massive. They're as big as the craters that would have killed the dinosaurs on Earth.
Yes, true.
The astronauts would have been. Obviously, the moon is in the Earth's shadow.
Yes.
How did these asteroids and meteors hit the moon from the direction of the Earth? Or was the moon angled elsewhere, outwards?
Yes, very good question, Phil. And my honest answer, and if the astronomical community would like to engage further here, but it's all to do with the early evolution of the moon as a natural satellite. And in doing so, may have positioned at a slightly different orbit as to how we currently exhibit it. And as a result, would impact the surface of the moon from a multiple of different angles. But I think that would also be a good question to ask to the board as well, just to ask for everybody's opinions too. So would anybody like to make further comments for Phil's question there?
I have an add-on question.
Sure thing, Jackie.
Yeah, hi. It may not, I mean, I could be talking out my ears here, but we're talking hundreds of millions of years ago. Could it be because the moon was not only closer to the Earth, but the Earth was spinning faster? So you don't get the face of the moon locked into against the Earth the way it is now. Is that an answer?
It's possible, or maybe the moon was spinning. It wasn't.
Could be.
I think that's the answer. The moon hasn't always shown the same face towards the Earth. Millions of years ago, when this bombardment happened, it was rotating in its own right. So every side of the moon faced outwards at some point.
So is what we call the dark side of the moon, is that equally cratered?
The far side of the moon, obviously the dark side of the moon is just nighttime, but the far side of the moon is much more heavily cratered. And that's because when it was trapped by the Earth to point towards us all the time, the back of the moon was then exposed to more bombardment. So if you look at pictures of the back of the moon from spacecraft, it's covered in craters.
Right.
It is. That's a very true comment, Bob, as well. And it's definitely worth taking a look at images from the likes of the Lunar Reconnaissance Orbiter, because it's so different to the face which we currently see, which is facing towards the Earth. So again, it's just one of those features, again, to look out for in your astronomical research.
Don't know.
So does anybody else have any more questions?
No.
No? Okay then, guys. I am aware that we are currently on 8 o'clock. So I'd just like to say thank you very much for all of your support this evening. And again, I hope to be with you very soon. And next time we'll look at deep sky objects. So I'll just get this up very quickly, just as the end of our talk here. and just screen share the ending slide for this talk. So we'll be looking at deep sky objects, which will be on Thursday, the 29th of April, 2021 from 7 o'clock onwards. And I hope to see you all next time. So I just want to say thank you very much, guys, for attending tonight. It's been lovely to see all of you. And I hope that this talk was of use to you for this evening. So thank you very much again for your added support.
Excellent. Thank you. Bye, everyone.
Lovely to see you all. Thank you very much.
Bye.
Thank you. Bye, guys.